speakers today,
This meeting is being recorded.
starting with Anisha Bhattacharya. Anisha Bhattacharya is an alumnus of the Institute of Engineering and Management, Kolkata. She's an incoming ML Research Associate at Adobe. Her main research interests include natural language processing, multimodal learning, and graph ML. And her today's topic is importance of research for undergraduates. So Anisha, without further ado, I request you to start your presentation. Thank you.
Hello everyone. To the students, like all those who are students here, I would request if you all can turn on your cameras. It would be good to see you all also. And let me share my screen. Okay. And so before we go to the slide part, I would request, like, if it's possible by the organizers to put a poll as to check, like, within the students who all are, like, is the majority from the first year in the undergrad or like their second year, third year in the undergrad, like that would help me streamline the talk a bit. Will it be possible?
Yes, we will just create it once. Shomodev, if you can create a poll, it would be very helpful.
While this is happening, let me introduce myself. So I am an incoming machine learning research associate at Adobe. I did my internships at Adobe Research, Julia Computing, and Umdena, which is like a non-profit organization. And I was one of the Adobe Research Women in Tech Scholars for the year 2021. So this is about me, and obviously I'm an alumnus of IEM. I graduated this year itself, like in 2022. So let me see the poll. Okay.
Shomodev, is the poll ready?
Okay, in case like poll is being difficult,
I will just
anyone
create a
can
performance point.
anyone can just unmute like themselves and say like they're like whoever registered, right? So you can tell me like who all are from first year, second year, or like later on, like third year or fourth year. Just to
maybe you can write in the chat box as well.
Yeah, that would be good. And if anybody can monitor the chat, because I cannot see the chat without stopping my screen share.
No, we will just inform you.
Yeah. Okay.
So I'll request the participants to mention their graduation year in the chat box and go.
Okay, so we have people from first year as well.
Okay, good.
So yeah, overall, I think most of the population is from first and second year.
Okay, that's good. And it's good to see like people are getting interested in research in general. So let me start my talk. So today's agenda would be to have a brief overview on research, make you aware of the opportunities that are present in research as an undergrad, because often when we hear about research, we think like that's for PhD students or master's students or like even postdocs and stuff. Importance of research, which is the talk title, and help you with some resources and briefly talk about my experience as in how this thing happened. So, and obviously, like, if you have any question, any doubt, I would request you to put that in the chat itself, and like in between we can make a stop and take any of your questions in case you have any. And I would like highly encourage you to like kind of interact with me, because otherwise it feels lots of boring stuff. I'm just speaking and speaking, and God knows what is happening there. So that would be very helpful for me in case you can communicate through the chat. Okay, so now starting the talk. So what is research? And this is a Wikipedia definition that I picked up. So it is the systematic investigation into and study of materials and sources in order to establish facts and reach new conclusions. Now, what happens when you are doing research as an undergrad, in suppose in an academic setting or in a company, you are given with a problem statement, like either a very specific problem statement which your professor or your supervisor is working on, or you are given like a broad problem statement and you have the freedom to choose your own problem statement. Now, what happens is the research study survey, in which you read through bunch of materials and sources like research papers, study blogs, and study maybe consult different types of videos, and you come up with some problem statement, and then you check your prior art, like what is already present in that domain, and try to improve upon it, or maybe use an existing architecture or existing model to your own use or to your own code. And that's what happens, and that's what is research. There is nothing fancy in there. Now, when we hear, like, this is the Society of Data Science, if I'm not wrong. So when we hear the term data science and artificial intelligence, it's just a buzzword. Like, there is so many things to it: deep learning, machine learning, artificial intelligence, fintech, chatbot, recommendation engine, so on and so forth. And once you start reading research paper, this GIF will make a lot more sense. Like, it's just equations floating around your head and stuff. So going beyond the buzzword, like many of you, like especially your or from first year. So what happens in our first year when we start our undergrad, start our engineering, we often find that, oh my God, AI is so interesting. We see these maybe LinkedIn posts or YouTube videos, and we are like, yeah, this is the field I want to be in. And then when we come, we are like overwhelmed with all these technologies in there and tend to get lost. And this is a very common phenomenon. Like, I guess I have talked to my seniors who have also said the same thing. Like, it happens to all and everyone. So going beyond the buzzword, we should try to analyze, understand that whether we are interested in AI research or we are just in here for the glory, like for the style and for just being part of the culture. So, okay, now I would ask you something. Can any one of you unmute and say what is the similarity between all these images on the screen? I guess it's visible. So can anyone just unmute and say? Go ahead, unmute. I guess it's not very boring in here.
No, I think many of them are still shy about speaking with their mics on. So
Yeah, you can, or you can put it in the chat box also.
yeah, you
But
can
I
put it in
would
the chat
prefer
box. The chat box is open for everyone. Please, if you don't want to put, you
But I
turn on
would
your mic.
prefer you to speak, because that's a good way of engaging.
So what
Like,
I see is
okay, don't message me directly. You can text in the chat, like for everyone to see. There is nothing to be shy, because I am a very shy person. I'm an introvert myself. So I am here speaking. That means you shouldn't be like
okay. One
shy
person
about
has answered. Vedant has answered clickbait.
it. Okay, nice guess. Okay, let's see other few people. At least one more answer and I'll be good to go. Come on, you should unmute yourself. Like, what will happen when you go to the interview?
This takes me back to online classes.
Even I didn't talk much in an online class, but still, I mean, see, it's not boring. I trying to make it like interesting. You all are too shy. You're
Please.
taking names and stuff. At least one person said something that's like good progress. You can use the chat also, like if that's speaking is too much, you can use chat.
I would like to say something.
Yeah, sure.
So this is from what I see here is basically they are focusing on the goal, which is just on getting a job and not really focusing on the journey, like what they would do after getting into it.
That's quite a nice answer. I mean, clickbait was a nice answer by Vedant, and given that he was the first person to say, I encourage the courage. Okay. So what I am saying is that one common thing that is there is that these are roadmap videos. I can see roadmap like in every of the thumbnail in here. And these are software engineering. These are for software engineering or product roles. Now, when it comes to my field, which is research, nobody made a roadmap. Like, believe me, I was so clueless, and many of you would be clueless too. Like, you can, if you're preparing for ST role or product role, you can go to YouTube, you can check blogs, and you can see like there will be generic roadmaps like do 500 lead code questions, follow this ST sheets, and you are good to go, and you can just go ahead and become a software engineer like just like that. But for research, nobody even talks about the jobs. So I am here not to present you with a roadmap or something, but at least to say, make you aware of the opportunities that are present and that you all can avail. So as a fresher, given that majority of you are from your first year, the first thing would be not to go towards these things, like go towards the buzzword, explore every other domain, be it just not artificial intelligence or data science or machine learning. Go and explore web development, Android, anything, cyber security. Because believe me, every other field is intertwined among themselves. So when I started with web development and later on moved towards machine learning. And believe me, that web development experience helped me a lot, especially when I was making the demo for the project or making this stuff like demoing to others or making a front end. That helped me a lot. So in your first year, just don't think like, okay, Didi came and said like she was doing research and she got a job, nice job, and I will just go and do research only. No, and this exploration part will be true for any phase of your journey, like whether you're starting as a fresher or a sophomore or like even later on. So that's one thing you should always do. Now, as in your fresher, you explored a lot and you found out like, okay, artificial intelligence is where I want to be. Attention is all I need. So in your sophomore year, what you can do is you can either intern with like under a professor, can be under your own college professor, or can be under someone who is from like a professor from other university or other college. You have to learn a lot because obviously AI is a vast field and nobody, like even the people who are like too well settled in their career in artificial intelligence, even they like those mentors that I've seen, they have also told that artificial intelligence you learn till you end your career. So you have to continuously learn new things, and this is valid. You can contribute to open source. Now there are various open source machine learning libraries, the bigger ones being TensorFlow. You all don't talk, otherwise I would ask like if you know TensorFlow or PyTorch or at least heard about them, would I encourage you all to say that in chat. in case you have heard about TensorFlow before. And also there is a place called Kaggle, which is there, and I did not, like, I regret myself not knowing it before. So in Kaggle, what happens is, if you have heard about the term hackathons, people go into hackathons and they make all sorts of projects and then they demo it, and then there are prizes and stuff. So in Kaggle also that things happen, but that is only like very specific to deep learning and machine learning. I'm not only saying like you can go to Kaggle and win those $1,000 prize or $100,000 prize out there, but you can also learn a lot from the experience. Like even if you don't win, you can explore these notebooks created by other members, other grandmasters, masters, and you will learn a lot through this experience. So Kaggle is a platform which I highly encourage you to check, especially in your second year or even in your first year. Like if you're quite confident about the fact that you want to make a career in research or in AI. Other than that, like you have to read a lot of research papers. Not by lot, I'm not saying that once you read a research paper, you'll understand everything, because research papers are intimidating because they are like lots of text with no images, no memes, nothing. They're just text and they are just lots of equations. And sometimes they look lots and lots scary. So even if you don't understand fully what I'll start like recommend, like if you're in your sophomore or second year, you should start a bit about reading research paper, even if you don't understand fully. And internships are always highly recommended if it's under a professor. Now let's move to the more lucrative part of the stuff, or as Vedant had I earlier mentioned, the more clickbaity part. Now, in your junior year, you can go for internships. I hope you all know about internships. What are they? So you go to an industrial setting and you work as an employee like for 3 months or 6 months, whatever is your duration, your time period. And you work there, you get your experience research. Now, these companies like Adobe hires research intern, I was one, Google, Microsoft hires research interns, Amazon hires applied scientist interns, as well as various startups like ShareChat, Julia, they hire interns as well. Now, these internships you can also try to get in your sophomore year, but it's highly competitive and they require you to have some knowledge of maths and machine learning, like in-depth knowledge to get into one of these. But these are as good as like your ST internships. Now, ST internships are so widely famous around people, but not research internships. So here are some of the stuff that you can explore in your junior year. And also not only like research, like internships in an industrial setting, but you can go for in the internships in an academic setting. Now, in academic setting, there are a few programs like you can see I've listed them. Like there is a program by Carnegie Mellon University, which is a very famous university. You can Google it up in case you don't know its name. And also there are various programs like by Rockefeller University, Princeton University, and you can check this link. Like I will send this PPT to your organizer and Shantan can send it to you. So, and these are some of the stuff I researched and got it for you. So there are opportunities by Stanford, Purdue, USC, and I have friends who have done these programs. Also, there is MyTax Global Link, which is an international research opportunity in Canadian universities, and one can check it out too in their junior. And this is only available to students in their junior year or their third year. So when you all go to your third year, you can try these out. And in for any of these, like availing any of these internships, be it in academic setting or be it in an industrial setting, will need somewhat of a stronger profile. So that's why I encourage you to explore and learn in your first and second year, so that you, when the internship season will come, you would be at ease to get all these opportunities and you will be knowing all these opportunities. Also, in case you don't want to be like part of these programs made in an academic setting, you can always cold email your professors out there. And also, these are some of the opportunities that are present in India. Also, you can cold email professors. By cold email, I mean you can reach out to professors, like mail them directly with your resume, your academic transcripts, and you can tell them, like, hey, I want to intern in your lab, and these are my interests. Is there an open position? And many a times you can get in through those stuff also, in case you miss them or you're not like sure if you want to apply through a program, you want to apply in person, that's also highly encouraged. And you can do it in your sophomore year also. Like these programs have their gateway, like these are get kept towards more like third year students or final year students. The cold email process can start anytime. Now, moving on to your final year. So, in case you are in your final year, you did internships in your junior year. So, one way, and you are like, I want to get this AI thing is for me. I want a career out of it. And I want to work in the industry for a bit in before like going to an academic setting or going in for higher studies. One easy way, which I also availed, was I did my internship at Adobe, which I got a pre-placement offer, which is like they offered me to join full time in the organization. So that is one way. But given that you didn't do an internship in your third year or junior year, or you did an internship but maybe in an academic setting, but now you want to move to industry, so in that case this roles, these companies hire in these roles like off campus also, so you can apply like aside from internship PPO conversion, you can apply generally also. So Adobe hires research associate or machine learning research associate, which is kind of my role. Google hires pre-doctoral researchers. Microsoft hires research fellows. Amazon hires applied scientists, and there are plus like many other startups which are also hiring for similar roles. Now, in case you don't want to go to industry because industry is a bit hectic, so you can go in for like you can work for as a research associate or a research assistant in like any of the big universities out there. I have a friend who is working as a research assistant at UCLA, and probably he will get a PhD admit there soon. So in case you're trying out like going for higher studies, but that favorite Ivy League of yours is not accepting you right now, so one way will be, or you have like a specific target, like this, I want to do my PhD under this professor, but that particular professor might be there is no vacancy, or your profile is not that ready still now. So you can always work under professors as a research associate or a research assistant, and hope like in 1 year or two you will be converted as a full-time PhD student in the same lab. Also, like in case you have a super good profile and you did your internships and you want to go like right of your undergrad, like when your undergrad degree is finished, you want to go for higher studies, you can always go through that also. So what happens is you need to apply like through GRE or the various other procedure, and you can apply for a PhD admit and you can go there and study. Also, Indian universities like IIT, ISC also hires direct PhD students, so you can check that out in Google. I don't know much about the admission process, but I've heard. Now, importance of research. Obviously, one is having a career, which I talked about, all these opportunities that research can give you, like lead code grinding or product development can give you high paying job in as an STE. Doing research or focusing on it can settle your career in one way. But there is more to any profession than mere the check or the finance part of it, right? So how does research help us as an undergrad? So it increases thinking ability. So in case even if you don't want to go like you did your internship and you're like, nah, research is not for me. Don't want to go to that field. You can go for product roles, but you will realize that you have a better thinking ability and better innovative mind than any other undergrad or your core workers in the product field. Also, research is quite interdisciplinary. Like research has its overlap with medicine, medical science, fashion, creativity, UI, UX, anyway. So always when you start working with AI, ML, you can always switch your branch or maybe specialize into a particular domain. Like you can have of specialization in fashion or creativeness. And you can always make these interdisciplinary projects which will help you in switching a career in the future also. Now, moving forward, before I talk about resources, I would like to know in case you have any questions out there, and then I will start with the resources part. Let me wait for 2 minutes, and you can always unmute yourself and speak as well. I think I'm not that boring a person or scary. Let's say so. Neither one of those. So, and we have some good number of people watching, so you can please interact a bit. That would be helpful.
If you have any questions, you can like put it in the
The
chat.
chat
Or...
is open and you can always unmute yourself. So
Yeah, both ways encouraged. I will wait for like 2 minutes before I go to the resources part and basically towards the end of the PPT. In case you have any question, you can ask. I know you all are first year students, so like it's okay to be shy and all, but you should speak. Because otherwise, like it becomes boring if the conversation is not both ways, if it's only one way. Right?
I think they don't have any questions right now.
Yeah.
So you can
Okay,
continue.
let me move on forward. I hope you all are listening and it's not becoming one of those online classes in which
Okay,
I
so
used to sleep.
so we have two questions. Vedant is asking, how did you find your research domain? Considering even AI itself is huge.
Yeah, this is a very interesting question. So, what happens is that I started off as a research or in deep learning as being a computer vision enthusiast. From computer vision, I moved to NLP. Now, when my internship started, I was very much like, I know a bit of NLP and I'm good at computer vision. This was my mindset, right? But my mentors and my internship, like when at Adobe Research, so the mentors I'm speaking, they are like PhDs and they are like hugely knowledgeable in their field. The first thing the director of our lab said to us that we shouldn't be very restrictive regarding our domain of research and should be open to exploration. And that changed my life because after that I've explored like multimodal learning as part of my research in Adobe. Also, I've explored GraphML, which I loved a lot. And even like often you think like one domain is very restrictive in itself, but imagine I used data structures and algorithms in my research internship. Like who thought about that? I never thought about that when I got my offer of research internship. So everything is intertwined and everything is there. And when you start doing one thing, you will find your way. Like research itself will guide you. You don't have to be so much like, but as a fresher, when you're starting, I would encourage you to learn a bit of computer vision, bit of NLP before diving into it. And then you will just find your way. You can even find your way in like an intersection of cybersecurity and AI, which is there, or an intersection of like interpretable AI, which is like how to interpret whatever the model is saying. So it's a big thing. Don't stress on how to find your domain will find yourself. It's more like Harry Potter's wand. Wand finds the person, not the other way around. And I hope you see Harry Potter to get that reference. Okay. First, Anubhav, please don't call me ma'am. Like literally, I passed out this year. And a fresher should start his career in IML and does not have. Okay, so that's why so here in the resources part, I will be covering that only. And I think that question will be solved over the course of PPT. And so just wait and watch, wait and listen rather. Okay.
We have another question here.
Good.
So here I have, I think, Mrunal, who says, what internship chances do we have after third year in AIML as a fresher?
Yeah, in after third year, you can go for a 6 months intern. Like like I'm talking about an industrial setting. So Adobe hires 6 months intern, Microsoft hires 6 months intern. These two I know of. I am not exactly sure about the other companies, but you can always check on LinkedIn. And other than that, you can go for this academic internships in case you're interested in going for a higher studies. And I think all of the universities do hire 6 months interns, but I think you need to apply through a cold email, like email the professor instead of like through the program, because the programs are highly like for junior year or like third year students who are starting their third year. So that can be a way. I hope that answers the question. So let's talk about the resources. Now, I told you a lot about how research can help you, how you can go to a good company or a good university, and how research in general helps you in your life. Now, as a fresher, how on earth do you start? So, these are some of the basic resources which is the Andrew Ng Coursera course. Now, when you hear the term AI, you have heard this man's name, Andrew Ng, like he's the god of ML and AI. So you can check out his Coursera course, which is like very highly structured for freshers or beginners in the domain, and that will give you a good grasp of knowledge. You can check out this Udacity Deep Learning Nano Degree. This is the course I learned from, and I like it. I have a bias towards it. So you can check out this course, and this course becomes like free through various scholarship programs. Like there's Bertelsmann Scholarship Program, the program through which I got it for free. And Udacity constantly gives out the scholarships, which has this nano degree as part of the package. So you can check Udacity's website or on LinkedIn for these kind of things. Other part would be Hugging Face course. So if you are like in your second year or even in your first year, you can check out Hugging Face. It's an amazing platform. And it has some free courses out there which are pretty good. Like it has its course going on reinforcement learning, which I am learning too. And it's amazing and very well structured. Kaggle has its own courses, bite-sized learning modules, which is more essential. Like if you have learned your basics from Andrew Ng or this Udacity course, you can revise using the Kaggle stuff, especially for interviews and stuff. Also, various universities like Stanford or MIT have their courses, like the courses that teach the classes online, and those lectures are highly worth it, and you can check them out. Check the resources and the assignments they share. They are amazing to watch. And I think there is a course called Stanford 6S291, which is an amazing course for people learning ML, like starting with ML. That's an amazing course to start with. Okay, now if you have learned your courses and done a few of your projects and stuff, one thing would be to read this research paper. Now, if you have been following my talk, I said research papers are very scary for anyone. So These are some of the resources that I found helpful myself on how to read a research paper. What they suggest is that when you get a research paper, read the abstract, skim through it, check your models and your output, and just verify like if this research paper is worth your time, or this is like something you want to read right now, and then read it in like peel it basically like an onion. Like you can read it first, another time skimming through the entire introduction, prior art and everything, and then you can go deeper and deeper as you can go. Now at first, like maybe by the second time you won't understand much, and especially if you're in your second year or first year, it's highly expected. But as you slowly continue reading, you will try to understand, and you will understand eventually. Now what happens is that some papers, like either you're in a hurry or you can't understand, and that also happens to every one of us. So you can check this YouTube channels by Alexa Gordick, who does research paper reading sessions. He's an engineer from DeepMind, and like I highly recommend his channel. Another is Yannick Kilcher. His channel is also highly recommended, and you can check out his channel, as in they do this research paper explanations. Also 2 minutes paper is there, which gives you a brief summary of the current art going on, like these massive models like Dolly, Dolly 2, or Imagen, these kind of fancy stuff. Each of the videos are like 2 minutes, so you can watch and check if you're interested in the paper. Now, some other resources which like alongside these things would be to check out this man's channel called 3 Blue 1 Brown, Grant Foundation. And believe me, I first, I regret it very much. I first found this channel in my second year, like towards the half, like later half of my second year. And I regret it so much. Like I should have found it out much sooner, because this man is a gem. Because if he taught you something and if you understood his entire video, you can like tell your concepts in sleep. That's how much confidence I have. There is another fun channel which is StatQuest, which explains these things like machine learning concepts, specifically the probability and linear algebra part of it, and it's nice. It's good. It's a good channel to check out. Also, MIT and Stanford and other universities, as I said, have the lectures online. For blogs, you can check out the Stewart's Data Science, which is a pretty popular channel, and it's an amazing way to learn. But obviously, learning is good, but if you want to get a job specifically in industry, not only learning and knowing things will help you, there are few other things that are needed, like data structures and algorithms. Like this is a non-negotiable part. And however we think like it is irrelevant, and I'm doing research, and how on earth am I linked to, like why should I do lead code and stuff? Believe me, I have given research internship interview, and I have friends who have given and cleared interviews as well in different companies. So you have one round in DSA, so you cannot skip it by any way. So DSA is highly, like it's highly encouraged to do DSA, not to the level of a competitive programmer, or like very high thorough level of DSA is needed, because see, STE put a lot more emphasis on DSA rather than us, like researchers, but still knowing it and knowing your concepts is very much needed. You need to read papers. Now, you don't need to read papers as in read everything in detail, but you need to keep up with this coming like latest research in case you're going for an interview. And also, it is good if you have a paper implementation kind of thing. Third thing is your resume. Now, your resume should have some quality projects in the field of machine learning and AI to get basically past the HR and even get shortlisted for an interview. Now, another thing is CGPA. Now, that's an elephant in the room, and we often say CGPA is not that important, but at least from my experience, like it's not super important, but it would be good if you have like a decent CGPA, say above 8.5 or above 9. Like encouraged. And especially if you are someone who is planning out for higher education at some point of time, I would love that. I would love if you have a good CGPA, because that's encouraged. And third, sorry, the final one is fluency. Now, for fluency, it's not like fluency in language or the way you speak, it's fluency in thought. Now, often, if you have heard about SD internships or SD interviews, what happens is that when you code, you need to explain your code as and while you code it. Now, as someone like I have appeared for one SD interview in my entire life, which was in Oracle. And the interview is pretty like technical. You are asked a question, you answer it, and while you are given a DSA question, you need to code it and speak while you code. Like basically, make the recruiter or the interviewer understand like you are coding it from your inside and you know the stuff. But in research, what happens that interviews are more based on discussion. So not only you should know things by heart, but you should make your interviewer realize that yeah, you know your things. And often in research internships or like one thing happens which is solution defense or even in interview, if you make a project, you should be like able to defend your project. You should be able to say that I did this model, I set up so and so hyperparams, or I took this training decision and I am here to defend it. Or you can share your outlook like, okay, that time I thought this was right, but maybe I can look out for an alternative. But you should be very clear and communicate your thoughts. And that's why fluency in thought is very much needed. Last part, which is suppose you like I shared with you some resources and some opportunities that you can avail to have a career in AI or ML. Now, obviously, like today in this is July, 10th July, and believe now if you go to Twitter or if you're active on LinkedIn, you will know that two big models that are up there in research is a Dolly 2 and ImageGen. Now, 1 year ago, when I was doing my internship in multimodal learning in Adobe, Dolly existed with no public code. Dolly 2 was not released, nor did ImageGen. So how on earth will you keep up with such amount of research? Also, opportunities are increasing day by day. Like some universities which did not have their internships, now they have their internship, there are new labs opening. So how to keep up? So the answer would be communities. So you can be active on Twitter, like tech Twitter, research Twitter is very active. And if you are someone who is like who likes nerdy jokes and wants to have this nerdy kind of sense of humor, you will enjoy that place too. And you will be aware of such other communities which you can be part of, like Hugging Face has their own community. There are various smaller AI communities which you can be part of. And communities have helped me a lot in knowing these opportunities so that I could apply. Now, last part, which is talking about my experience. So I was in my first year when I was not even interested in AI and ML. I had friends who are interested in AI and ML. I was not. I was doing web development. Then I slowly from web moved to Android, then moved to, I think, some other field. Then I realized that is not for me. And at the end of second year, I guess, I was like, yeah, AI and ML is somewhat something that interests me. So I started learning. Now, as I said, now one thing, many people out there will say like, buy this course, this would be helpful, that would be helpful. Believe me, from my experience, I've never bought a single course. Like I've never spent a single money on online courses or on any other stuff out there. Like it's like excluding my degree, which is there, but other than that, I did not pay a single thing. Everything can be availed for free. Now, these Coursera, you can check in Coursera, which gives you financial aid. So I started with this Udacity nano degree. So there was this Bertelsmann scholarship which was going on. So I enrolled for the scholarship, and luckily I got into the cohort and I worked hard. So when you are at first, what happens, you're given like 4 or 5 modules free of cost. If you do your exercises well and if you are active in the community, you would be given a fully funded nano degree free of cost. And nano degrees, Udacity nano degrees are expensive. So that happened, and I got my Udacity deep learning nano degree, and I started my journey officially into this world of deep learning and machine learning. Obviously, alongside follow some of the blogs and stuff. So this was going on, and I was also practicing DSA. And at the start of third year, I was also applying for various internships, ST internship, product internships. And what happens, like being a tier 3 college, often what happens, you apply for something and you get rejected. Like maybe you don't get the online assessment, or sometimes you get the online assessment, you solve it, and you're like, nah, they don't call you, the HR don't, like, they just ghost you out in random. So these things did happen with me also, and with every rejection it hurt. But there was one opportunity which was there, Adobe Research Women in Tech Scholarship. Now this scholarship, it's pretty wild because it's given like literally to 6 girls in India, like in entire India, it's given to 6 girls. So when I applied for it, I had zero hopes, but still I got my LOR, I got my academic transcripts and everything, and applied. And in December 2020, like at the end of my third year, I had my first technical interview with Adobe Research from staff in Adobe Research. And it was so awesome, and they are so sweet and so encouraging. That just boosted my confidence from here to here. And I got, eventually I won the scholarship by God's grace, and then the internship happened, and now I will be joining full-time in the industry as a research associate. So why I told so much long a story is that at one point you would be like, nothing is working out for you, like I was when I was rejected at ST internships. But now I realized like ST was not my cup of tea, and I was not that interested in that field. So maybe if I had gone there, it wouldn't have been a wrong decision. So I got my research because I was rejected somewhere in my ST roles, and got into research as a career, I'm saying. So these things happen in research. Like in my internship, what happened is that I used to get overly attached to my code, and I used to be like, this model should work and stuff like that. And people who are into data science and research, you will all, I guess, agree with me that sometimes we tend to get attached to our models and codes. And that thing, Adobe taught me a few things, like don't get attached to your codes, don't be attached to your domain, like you should be open to exploring other domains. And that's what I'm saying from my experience, that you should not be attached to your code. You should be like agreeing to revisit and reiterate and change your codes as and when is required, your models and stuff. Keep an updated resume, I would say, because like the wise men say, like if you cringe at your previous resume, that means you're growing. So do that, and maybe try to get internships, and internships help you a lot. The learning curve is steep, but you learn a lot of things, like in general in your coding principles as well as in your career, you advance a lot through internships. So these are some of the things I can say. As an undergrad, you can, following this route, you can always have a career in research. It's not like you only need to go in by your very specific roadmap or very specific for the very specific roles out there in the industry. I think I am quite at the end of my talk, so I would like to take any questions if there is any.
Yes, so Rudra Jha has asked one question: is how much DSA is sufficient?
Okay, so I would say that uh, you don't need to do competitive coding if you're not interested in that stuff. But DSA, as in you need to know algorithms, and like you need to know them well, and you should be able to handle interviews. Like you can go on lead code and do like easy medium level questions, and maybe a few like famous hard problems, and I think that would be enough and sufficient. Like from my experience or my friends' experience who are in research. Other than that, do you have any questions?
So that there was this question as to which YouTube channel you had mentioned for the explanation of research papers. So I think it was Alexa
Alexa
Cordage, right?
Gordic, yeah, the AI Epiphany.
Yeah, everything. Yeah. So
Yeah,
I
that
had
is a
looked
very
into that.
good channel. Also, you
Yeah.
can check out Yannick Culture as well. Like he explains the papers quite well. And there are others, like if you want a specific explanation, like for a paper, you can just type the paper title and explanation, and you can even find the authors explaining the paper, which is like the best resource, I guess. So that's also there in case you're thinking.
Okay, so we have another question. Considering every professor receives so many internship applications, what can we do to make our application stand out?
Yeah. And this is not only like true for this professor, like academic setting internships. This is also true for industrial internship as well. So what you can do is you can make quality projects. By quality projects, I mean you can do something like you can take up a paper. Not has to be super like advanced paper. You can take up a bit older paper as well, and implement it. That counts as a valid, nice, project. Other than that, you can go for open source contributions. I think you can contribute to these communities like Hugging Face, Julia, TensorFlow, and these make your profile stand out. Other than that, I think personal projects and open source and Kaggle, in case you participate in contests, those help your profile to stand out. And try to get, when you are sending a resume to someone, try to get it reviewed by like either your peer or your senior who are in this field, because that helps a lot. Because sometimes when we are making, like I remember my first year resume, and it's probably the cringiest resume you can ever find. So you can always seek guidance in these matters, and it's best in my opinion. Okay. Is there any other question?
I don't think we have any other questions. So maybe if you could just stop sharing your screen.
Yeah, wait a second. So in case you all were so shy, but in case you have any other doubt, you can always like go to my Twitter account and DM me over there, or in case you don't have Twitter, you can DM me on LinkedIn. I'm more active on Twitter, by the way. So any of these two will work, and I'll send this PPT with all those internship stuff, and I think it will help you. So that's it. Thank you. And let me stop sharing. I hope you all liked the session.
Yes, it was very, very insightful.
Yeah, I'll send the PPT to Shayantan, I guess, later on.
Okay, I will share it with the
You
participants.
can share it with your community. And thank you, everyone.
Thank you so much, Anishati. So we have Amol sir here, who is the president of S4DS Pune. So I would request Amol sir to give the token of gratitude to Anisha.
No, it's really nice, and I think student must have got it from horse's mouth. So this is a nice effort, and thanks, Anisha, that you properly and very thoughtfully prepared this PPT and explain. And definitely, there were few questions about how to get into and all that. So my first and foremost answer to all of you is that please come out of copy paste. That is dangerous. If you really want to come into research, do your own work. Maybe it is a small work, but it should be your own and personal work. So people will immediately recognize whether it is your personal work or you have done copy paste and so on and so forth. So this is very important. So don't try to do the work which is of large scale or big enough, because sometimes you count on the scale whether my data set is big, whether my work is big or small. So don't do that. Find out the real problems or your own original problems and then come out. So thank you very much for delivering the lectures.
Thank you, sir. Thanks a lot.
So thank you so much, Anishadi, for joining and sharing your knowledge with us. And we would like to see you again in more such webinars. So I think, Nirmala, we can move on to Atul sir.
Yeah, so I can see Atul sir has joined.
Yes, good evening, sir. Welcome to Society for Data Science webinar series. And to give a brief introduction about Atul sir, Atul Bangeri sir has over 22 years of successful track record in digital transformation in the IT enterprise, government, healthcare, education, smart city segment, and whatnot. He is a director of Acumen Today and academic specialist for various educational institutes in India, Far East and Southeast Asian C countries. So thank you, sir, for joining. And Atul sir's topic for today is leveraging data science and ML in large companies. And I would request you, sir, to start your presentation. Thank you.
Yeah, thank you so much for this warm introduction. I would welcome all of you on behalf of Society for Data Science and personally as well. I was going through the earlier presentation, of course, at the fag end, and I'm tempted to share some of my experiences as well, which I will do while I go through my presentation. So if I'm allowed to, oh yes, yeah. So let me start with sharing my screen. Okay. Yes, before that, let me just look up to the power. Just give me a minute. Okay, just to confirm that you're able to see my screen.
Yes, so we can see your screen.
Okay. So before starting, I would like to thank Dr. Amol Goji and Dr. Neha Sharma as well for giving this opportunity. Right. So straight into what the topic is all about: machine learning, data science, artificial intelligence, especially with a focus on the industry. And what I'm going to talk is something that a few of us know, something that a lot of us know, and something that we will get to know. Right. So make it interesting. Keep it on the chat. I'll pick it up in between when we take a small break for taking up the questions. I can see something already. Okay, yeah. Okay, so somebody will moderate and we will take it up. Okay, so let's start with understanding Industry 4.0. I want to set the context before we go deep dive into the specifics of machine learning, right? So it's important that we all understand and know where we are and why we are where we are. So we have heard of Industry 4.0. We have come a long way from where it was probably 2 centuries back to where we are today. And there is quite a quantum leap that we have taken. It's a wonderful and an interesting era that we are all in. Thankfully, we are experiencing it on a day-to-day basis. Now, what is this all about? It's all about how the industry revolution has happened over the years and enabled all of us to be part of it, either through learning, through academics, through career opportunities, through research opportunities, and a whole lot of things. But then it's important for us to know that in the first industrial revolution, it was all about mechanization and using steam power, which was mainly single machine for many users. Now look at the way scenarios are changing, okay? Single machine for many users was what was the characteristic of Industry 1.0. which was the foundation for where we are today. I'll get to that. Look at what happened in the second industrial revolution. Many machines and many users, which means to say that mass production became the norm. Assembly line and use of electric power came into existence for mass production. This was something just before World War started. And then from then on, we are seeing a lot of automation and use of computers and electronics, which made way for digital revolution and digital transformation to some extent, wherein many machines for each user. Now I am the user, and there are many machines for me to use, not just one or two. Now, fast forward to where we are today, 2010 onwards, we are talking about Industry 4.0, wherein we are talking about cyber physical interface and Internet of Things, Internet of Everything, and Internet of Networks, wherein this is where the digital transformation is actually taking shape and is the power loom of Industry 1.0 is transformed to the power that we have today, which is the digital power. And when I talk about digital transformation, there are a lot of components into it. We will talk about it. But here we are talking, of course, many machines for each user. We have many machines for many users now. And then everything is becoming smart. And that's where machine learning, artificial intelligence, deep learning, and all of it is taking shape. Now, the other thing that you all need to know is that Industry 1.0 and Industry 2.0 didn't create much of a data. There was no data as such, right? There was a lot of mechanization. There was an attempt for automation, but not focusing on the data. Forget about data engineering. There are a lot of engineering that was used. Electrical engineering, mechanical engineering, civil engineering, and a whole lot of stuff came in. But data came into existence only from Industry 3.0. And even in 3.0, there was hardly any data. If you ask any of your seniors, they'll tell you, we were involved in building systems that would be capable of collecting data. Now, collecting data at that point in time would be data entry, human intervention. Today, we have come to a stage wherein I don't need any human intervention whatsoever when I talk about data. That is Industry 4.0, which is leading to digital transformation. You talk about Industry 4.0, and this is what it's all about. It's all about big data. Now, we no longer talk about data, we talk about big data. Now, big has its own connotations. It's for you to go onto Google and look out to what are the characteristics of big data, but we are dealing with humongous amount of data. The definition of big data has changed over the last 2-3 years. Initially, it would be anything beyond 1 terabyte would be considered as big data. Today, my laptop has 1 terabyte of storage available. So 1 terabyte is no longer big data. But then it's not just about the size, it's about the complexity, it's about the form, it's about the format, it's about the stack from where it would come, it's about the sources of the data that would make it even more complex. If I talk about structured, unstructured, semi-structured, and other formats, which would be the XML, JSON, and probably audio, video, all of it, it becomes even more complex, right? So all of this put together is leading to complete disruption in the way we look at data, because there is no longer user-generated content that is of importance. It is machine-generated content which is leading to the spurt in the data that gets generated. It is no longer human intervention that is needed. Machines are creating data for themselves. Machines are interacting with various different machines in an automated environment. We are in a connected world. Thanks to the system integration and a whole lot of network capabilities that have helped us, of course, with a lot of compute power and storage power and all of it, which has made it possible. And this is what digital transformation is all about. It's not just about technology and communication and data. It's about a whole lot of other components and elements which is making it possible. And digital transformation is the way forward for any industry. We have seen digital transformation happening in the banking industry, BFSI. We have seen it in the automobiles industry. We are talking about driverless cars today, smart cars to driverless cars, right? So there is a lot of automation happening and a lot of artificial intelligence that is being built. Now, we never heard of artificial intelligence a decade, 2 decades back when I started my career. Why? Because there was no data to work around with. Artificial intelligence will come only when there is data. Till recently, it is the human intelligence that was needed. But now we need both. We need the machines also to work for us. We need the machines to provide us with some insights and some automation which can be done without any errors, because machines can't go wrong. Of course, if I provide garbage, it'll throw garbage, but that's where human intelligence is still superior, and it'll remain so, at least in our lifetime. I don't know what will happen later on, but nevertheless, this is a wonderful era to be in, wherein we are in the connected world, and data is the fuel. With the fuel price rise and all of it, forget about that. Data is the fuel. Start looking at data to be the next fuel. Okay, data, the new oil, right? But then I'll take it a little forward. Data is no longer the new oil. It's the new water we drink, and it's the new air that we breathe. It's become so very important. That's a different story. We will take it some other day. But look at the data that gets generated in a day. Whether it is social media, whether it is machine-to-machine learning, machine-to-machine interface, whether user-generated content or automated content through the Internet of Things, intelligent Internet of Things, Internet of Everything, right? So humongous amount of data being generated. Just for your perspective, I'll share the presentation later on, which you can access. And there are a few links as well, which can provide you with more insights. But nevertheless, so the transformation is all over. While we talk about digital transformation, it also leads to process transformation, business model transformation, market transformation, domain transformation, and organizational transformation. It's been an age-old technique and tool that we use in any business for bringing about change. It was IT earlier. It is data now. It is transformation. It is digital transformation that we talk about. So it is helping in improvising your operations, improvising your processes, improvising your business models, improvising your back-end operations, improvising your domain expertise, whichever domain you may be in. You may be in banking, you may be in education, you may be in governance, you may be in transport, you may be in probably smart cities. You could be in any domain. There is disruption happening and transformation happening as we speak, and this is not going to stop. It's a continuous process. Thanks to digital transformation, thanks to technology at our hand, we have become more data-driven than ever. Anything you talk about, whether it is marketing, whether it is your strategy, whether it is your product, whether it is competitive analysis, everything is data-driven. Not that it was not. Earlier, it was to a limited extent. Today, there are multiple parameters that govern and influence all of this. So there is no question, there is no doubt that Everything is data driven, whether it is government policy, whether it is any promotional activity. Look at e-commerce. E-commerce is such a wonderful example of how the tweaking happens on the fly. The recommendation that comes up, the suggestions that come up, the pricing that happens, it's all dynamic. More the demand, more the price. Or maybe launch to generate the hype. There are various different ways in which multiple algorithms are put to work in the backend. I will talk about this, taking a few examples, but I want to set the expectations. I want to provide you with something that will cater to your 360-degree thinking. Now, what is that? An eye for data. I know you heard the speaker yesterday on outliers. Yes, very important to know what outliers are, to handle outliers, to eliminate outliers. All of that is fine. But I'm wanting to take a classic example. This is something which was doing rounds on LinkedIn a few months back, and I just loved it. So I want to share with all of you because there are multiple ways of looking at the data. Machine learning is very boring. I'll tell you why. Yeah, you may be surprised hearing this, but it's very boring. Whereas looking for data, an eye for data, an ear for data, a sense of data is very important. Now, the image that you're seeing here is an image that of a fighter plane. It was not a fighter jet then, a fighter plane of one of the countries during World War II. And the white space and the red dots is what I want you to focus on. The red dots are the various different places at which the plane was hit. They analyzed, okay, let me tell you, during World War II, yeah, I'll just read it out and then explain. During World War II, fighter planes would come back from battle with bullet holes. The red ones are the bullet holes that you're seeing. The Allies found the areas that were most commonly hit by enemy fire, right? The Allies, the ones who were against Germany. They sought to strengthen the most commonly damaged parts of the planes to reduce the number that were shot down. Yeah, obviously, you're seeing that the bullets are hit, and you would want to strengthen it or ensure that the bullets don't get hit so that you save lives and you save the plane, and probably you win the war. Whereas a mathematician, Abraham Wald, pointed out that perhaps there was another way to look at the data. This data is wonderful, visual data. But a mathematician, he said, perhaps there is a different way. And his logic was, perhaps the reason certain areas of the plane weren't covered in bullets, you see a lot of white area where the bullets are not found at all, but that the planes never came back. Right? Was that the planes that were shot in those areas did not return? They didn't come back. They were shot and it was fatal. This insight led to the armor being reinforced on the parts of the plane where there were no bullet holes. Look at this. Now, the outlier principle would be applied if I were to look at the dots or the white lines, white spaces. Which one? The outliers in this case are not the red dots, but the white space, right? And that is exactly what the story is all about. This may be not having any relevancy as such at that point in time for data science, but in today's world, it definitely plays a major role. And never forget this. No data is irrelevant, even if it's an outlier. Probably an outlier is the place where you find a solution to the problem. Whereas machine learning will not know this. Who will know? It is you and me. The data scientist in you and me will know exactly what to focus on. This is the reason why I said machine learning is boring, whereas I can make it interesting. Right? Yes, the story behind data is arguably more important than the data itself. Yes, the data talks for itself. Yes, the picture talks for itself, but the story behind the picture, the logic behind solving the problem of the picture is more interesting than the picture itself. Right? Having said this, let me take you forward. So let's come to machine learning. Okay. While it may be boring, I'll make it interesting now. It focuses on development of computer programs that can use data and use it for learning it on its own. Right? So it's all about getting more examples, observations, experiences, and then provide the instructions. In order to look for patterns, I need to look for patterns. I need to connect the dots and make better decisions in future so that I have multiple such examples. The example that I showed was that of World War II. If you skim through, or probably if you get involved, you will have multiple such examples which you would learn on your own while you are learning machine learning. Okay, the primary aim of machine learning is to allow the computer to learn on its own. And there are ways of doing it. Okay, without human intervention or assistance, and adjust the actions accordingly. The classic example would be a driverless car. There's so much of machine learning involved in it. You name the machine learning algorithm and it would be put to use, right from computer vision to probably regression analysis to probably decision tree to maybe even LSTM. I will talk about it. The best part is we have to teach the machines to learn on its own, and we need to now learn how the machine learns. It's a two-way learning. While we are teaching the machine to learn, we are also learning how machine learns. Are you getting the point? Yes. So that's where we are saying that we are teaching the machines to learn, whereas we are also learning how machines are learning. It's like going back to the future, wherein we were talking about assembly level language earlier. It's come back in a different form. We'll not get into that. Okay. Machine learning methods and algorithms. There are hundreds and thousands of them. Let me just put it in the perspective, right perspective. Simple, right? Different types. You would have heard of this. Let me just skim through it. Supervised, unsupervised, semi-supervised, and reinforced. Supervised, as the name goes, there is a lot of human intervention that is needed. So there would be a human touch all the time. And under supervised learning, you have the regression and the classification types. And for each of them, you can read out the examples. Under the unsupervised learning, it's unsupervised. So I'm not supervising. I provide the necessary inputs and the machine would learn on its own. Clustering is a classic example of unsupervised learning. There's also semi-supervised learning. I would sometimes intervene, supervise, and sometimes I would not. So semi-supervised learning, which is a combination of both clustering and classification, speech analysis, speech to text, text to speech examples that are already there. Now, this one is what I was talking about, right? Self-driven cars, reinforced learning or reinforcement learning, wherein it is a combination of classification and control. This is where it would use a lot of your compute power, a lot of storage power, a lot of logic, and a lot of decision-making power. Any questions? Anybody asking any questions? No, not yet. Okay, nevertheless. So to get it in the right perspective, wherein we talk about artificial intelligence, machine learning, and deep learning, this is a diagram which you need to know and understand as to what drives different components of data science. All of this is part of data science. Whether you talk about machine learning, whether you talk about artificial intelligence, or you talk about deep learning. And in the order of preference. Yes, sorry.
So machine learning is only applicable for digital machines, or it also applicable for analog and the physical ones?
Oh, well, analog machines were using a lot of embedded computing earlier. So there was some element, some component of machine learning already there. It was not called machine learning though. It was assembly level programming. which would do the stuff that it is intended to do. For example, a fax machine. You wouldn't have, means we don't see them now. Probably, what other example can I take? Okay, so industrial machines which would necessarily do a specific task. For example, a punching machine which would create a die, use a die in the bottom, and use a moving piston for creating the impressions on a metal sheet, right? It would do only that. So machine learning is not new, whereas it was named as assembly language or assembly programming earlier. But yes, that was very rudimentary. Whereas today we have machine learning, which is not only for human and machines, but between machines and machines as well. We are in industry 4.0. So cyber physical interfacing, IoT, the Internet of Things, everything being connected, right? So that is the perspective from which you need to be looking at. So when I say cyber physical, it includes the analog machines as well. The analog machines are also part of my connected world. So they are part of my Internet of Things, Internet of everything. Okay? Yes. So having said this, let's look at some of the components that go into all of the good things that we are talking about. Artificial intelligence, of course, advanced analytics, IoT, which is Internet of Things, industrial Internet of Things, Internet of Medical Things, IOMT, right? The Fitbits and the wearables that we are wearing, right? Then the RPA, robotic process automation, which is mainly driving our 3D printing as well. Okay. Then autonomous things. This is an extension of the Internet of Things. It is Internet of everything, right? Which is having its own capabilities to decide on its own, like the driverless car. Immersive experience through virtual reality and augmented reality, and then of course blockchain. So all of this is not only the components that you need to be looking at for digital transformation, but also opportunities for the next decade or so, which is leading to a lot of job shift. Okay, having said that, let's come to the basics. Yes, any questions? Okay, first understand the difference between analysis and analytics. Why are we talking about this? I want to set the context for what I'm going to talk later. Analysis is not analytics. Of course, yes, the spellings are different. So naturally the meaning will be different. So would be the input and the output. So yes, so data analysis is not necessarily data analytics. And of course, business analysis is not necessarily business analytics. Okay, this is like playing with English words. What does this actually mean? Okay, let's take it little forward, one step at a time. Wherein, when I say analysis is not analytics, I will talk about the process of data analysis and the process of data analytics as well, keeping in mind the application of data science, which would include my machine learning algorithms and the data processing and analysis. What do we do, and the outcome and the presentation and all of it, right? So it's important we understand this before we go forward. So first and foremost, my data analysis process starts with the understanding of the business. See, business transformation is happening, and there is a lot of data that the business is generating for itself. So that's the reason why I need to understand the business. That's when I would define as to what is the analysis that I will do. That is when I lead to the next step of understanding the data, wherein the data which comes from various different sources has to be qualitatively analyzed and assessed. That leads to the data pre-processing, wherein I need to do a lot of data cleaning, data editing, data reduction, data manipulation, and data transformation. This is what we also call as feature engineering. Now, when I'm doing data pre-processing, that is where I would look at the outliers. And then I would start doing some analysis on this data, descriptive, exploratory, predictive, analytic, right? All of this analysis on the processed data. And then, of course, results, interpretation, evaluation, and then reporting it out. Every stage is important in the journey when I look at data analysis. And look at what data analytics talks about. Data ingestion. Now I take the data, yes. Data cleansing and transformation, yes. Something about data pre-processing. And then dimensionality reduction is all about how do I reduce and how do I slice and dice the data? How do I focus on what are the data elements and what is the data that I will be focusing on? And then I will do some analysis and then visualization. Any difference? Probably no. Both go hand in hand. The process remains the same. But what do I do at different stages would actually define the difference between analysis and analytics. Now that I have spoken about the process, let me tell you the difference. Analysis is what I do on existing data. It is like conducting a post-mortem on the data in terms to know what has happened and how it has happened. It is like creating my MIS reports, management information system reports, my executive information system reports. It is like giving a report of what things have happened in the past. But analytics is one step forward, wherein it can provide you some insights, provide you with some trends, provide you with some sneak peek into the future as to what could happen. This is where you will start playing around with data, business, domain expertise, and machine learning algorithms to know exactly what could happen tomorrow. It is like predicting the future of tomorrow, predicting the future of the business, predicting the future of sales, predicting the future as to what could happen if I launch a product tomorrow. Very important. And not just one prediction, I would have multiple variables, multiple parameters on which I would decide what would be the best fit for me. So ultimately, while I need analysis, analytics is helping in providing more insights for decision making. If you remember what I had told earlier, I had told that everything is getting to decision making through data-driven decisions. This is what it is. So let's take a look at the data analytics process. Now that we have come there, this is where we will start looking at where machine learning algorithms actually play a role. Data preparation is what we have already spoken about in the earlier slide. This is where I would do a lot of, in the first step, which is data preparation, I will do a lot of data modeling and data sourcing, data cleaning, data pre-processing, and all of it, right? EDA, the exploratory data analysis, is where the data analytics entities and components will start taking shape. The outliers, the application of some of the machine learning basics, whether I would go with supervised learning or unsupervised learning or a combination of two. And if it is supervised, which one will I use? If it is unsupervised, which algorithm should I use? The logic for using the algorithm is also very important. And that depends on the objective. The objective is basically to find a solution to the business problem. And then look at the data as to how the data looks like and what could be the best fit when I apply the machine learning algorithms. And then data visualization would be an extension after I do the complete analysis of it. But yes, classification, clustering, and predictive analytics are all governed by hundreds and hundreds of machine learning algorithms. And of course, artificial intelligence would come later. Let me take some examples. Yeah. I've picked it up from Gartner. Gartner is one of the leading research and consulting agency. So these are 4 different analytics that we have. Descriptive analytics tells us what happened. This is the age-old stuff wherein I'm using the OLTP and the OLAP, data warehousing, data mining techniques, and all of it, which is basically to create my MIS and EIS reports. Then I go to a little bit advanced, wherein I'm doing diagnostic analytics as to why did it happen. I'm trying to find the RCA, the root cause analysis, wherein I will do some analysis on the existing data itself, wherein I will do the sentiment analysis, semantics, and all of that. We use a lot of sentiment analysis in today's e-commerce world, customer sentiment analysis, right? So we are leading there. But the interesting part is when I do predictive analytics and prescriptive analytics. Look at this. Predictive analytics will give what will happen. It's not what will happen, what may happen, depending on various different parameters. This is where I will do some pattern matching, the pattern recognition, right? Connecting the dots, identifying some insights. I'll do a lot of statistical analysis. Till now, I have not taken statistics seriously at all, statistical analysis. But there are multiple statistical analysis algorithms that are available, which can be made use of, which can be put to use for my predictive analytics and prescriptive analytics. All of a sudden, computer science engineers are made to look like fools. Yes, because we have been focusing only on the computer engineering side of it, building programs over programs over programs. We never focused much on mathematics or statistics. All of a sudden, because of the amount of data that we have, I need to start applying a lot of mathematical models to it, a lot of statistical models to it. And then the engineers like me who started 20, 22 years back have started to look at it in a different perspective. And what is that perspective? I no longer worry about the programming. I no longer worry about writing a program or writing an algorithm, because everything is available to me through various different tools that I have. It could be Python, or it could be R, it could be a lot of other tools that I have from companies like Microsoft, Oracle, Google, and all of them, right? That's a topic for some other day, but I can look at forecasting. I can do some regression analysis. I can do some prediction. Not that all predictions will come true, but to a large extent, if I were to take an example now, it's the weather forecasting. Forecasting is what you do for the future, right? Weather forecasting was never right, probably 10, 15 years back. We used to laugh especially when we used to see Doordarshan. If you remember, you can ask your parents or elders. Doordarshan mein jab weather news aata tha, kal ka weather batate the. They used to tell us, right, after the news. We would all laugh it out, saying that if they are saying that it's going to rain tomorrow, take it for granted that it is not going to rain for sure. Right? That was the confidence we had. But today, they will give you accurate forecasting, accurate prediction, especially of the rain, to the hour. Some can go up to probably 15, 20 minutes accuracy. That is because of the maturity in the way we have started using our algorithms. And thanks to humongous compute power, storage power, and the data that is available for the last 30, 40 years. 20 years back, I didn't have any data that I could analyze. Today, I have a lot of data that I would analyze and then probably do some analytics. That is what we are looking at. Now, going one step forward, the prescriptive analytics provides you with inputs and insights as to how can we make it happen, right? What are the various different components that are needed? What are the various different tasks and activities that you need to undertake to actually achieve what you want to achieve? So that's where our neural networks, the deep neural networks, artificial neural networks, recurrent neural networks, and all of it come into play. So we are using algorithms, we are using data, and we are using our own intelligence to build all of this. Sounds very interesting, but yes, there is a lot of rigor. And what is the rigor? Let me talk about it. So talk about multiple algorithms. I've just taken a few very commonly used and most easy to remember algorithms from various different either supervised or unsupervised and some reinforced, right? So linear regression, logistic regression, LSTM, which is mainly a long short-term memory, right? Very interesting. After this, probably you can do some Google and do it for yourself. Decision tree, random forest, reinforcement learning, k-means clustering, ANN, and RNN, DNN, a lot of things that would come in, right? Not to scare you, but to let you know that it's an ocean. Machine learning, artificial intelligence, rather data science in itself is an ocean in itself. Right. So any questions? Let me just pause if there are any questions on the chat. Okay, nobody. So no worries. Let me go forward. What happened? Yes. So let's take one case study. We are all grappling and we are all hearing a lot about supply chain issues, right? So I thought, let me take this up. The challenges in supply chain that machine learning can solve. What are those challenges? Right? So majority of the companies don't have complete visibility of their supply chains. Yes, 69% of the companies don't have that insight from start to finish. I need that. I need to know in this competitive world as to where my individual component, forget about the finished product, where my individual component is at present. So which is mainly, what are they? Poor resource planning. Yeah, I cannot plan my resource because I don't know when it is going to be delivered, when it is going to get into my warehouse, when is it going to leave from my unit. And my unit could be not just of that of a supplier, but that of a manufacturer, but of a storage guy as a warehouse, right? Inefficient supplier relationship management. Now we are having a lot of these techniques in the supply chain management industry. One of it is JIT, which is just in time. Now, just in time requires a lot of coordination and very efficient supplier vendor relationship management. Well, while it has been a concept, a few companies like probably Toyota. Sorry, yes, anybody? Any questions? Can I request you to go on mute if you are not having any questions?
Yes,
okay, yes.
I have muted it.
Yeah, you have a question?
No, sir, I have muted the person. So you can continue.
Okay, yes, please. Thank you. Yes, right. So that is on the supply side of it. But there are a lot of insights that I need to know after the supply, which is at the customer side. We are not only talking about customer satisfaction today, we are going to influence the customer preference. We are going to influence the customer buying pattern. We are going to influence the customer behavior. And for that, we need a lot of data, and that is not available. Quality, safety, technical downtimes, cost inefficiency, transportation costs. Now, just imagine if I don't plan it properly, my transportation costs are going to rise. And with the rising fuel price, if I don't manage it properly, if I don't plan it properly, my cost to the company, right, which is again the bottom line and the top line, the TCO, the total cost of ownership, has to be as low as possible. Otherwise, I will not be competent. And the determining pricing is what will make me the leader. And if I can do all of this, I will be the market leader. Some of the companies who are into supply chain, Toyotas, Amazons of the world, they are mastering this, and they have figured out a way that, yes, machine learning algorithms, machine learning basically in the backend, can help them solve most of the problems which are catering to all of this. Let's take a look as to what are the benefits. Cost efficiency can be built in, which systematically drives waste reduction and quality improvement. Yes, it's all about data, right? The more data I have, the more data I will share. The more data is used for planning, the more data is used for strategy, the more data is used for decision making. It becomes a well-oiled machine that will be very, very efficient. And once it is efficient, my costs will automatically come down and quality will improve. Yes. Optimization of product flow in the supply chain without the supply chain firms needing to hold much inventory, the just in time that I spoke about. I don't need to stock up my inventory, which is eating into my real estate cost, right? If I ensure that the product flow is just in time before it goes into my production, and the produce, which is the end product, leaves my premise as soon as it is produced, I am wonderfully enabled to not only look at my supply chain from the suppliers and vendors, but also supply chain to the end customer. A wonderful state to be in. Many companies have done this very, very effectively and efficiently. So this I spoke about. Seamless supplier relationship management due to simpler, faster, and proven administrative practices. Yes, order placing, order management, purchase, delivery, payment, and a whole lot of stuff that is getting automated at the back end. And machine learning helps derive actionable insights, allowing for quick problem solving. Yes, problem solving, which is not dependent on any data that I don't have access to. Now, if at a click of a button or touch of a screen, if I have the data, I can decide faster, and it'll help me in continuous improvement, right? So having said this, this actually holds good for all the industry. While I took the example of supply chain management, now how is machine learning going to help? Now this is a chart, this is a cheat sheet, wherein you will get to know which machine learning technique or which machine learning algorithm you can use for solving a problem. Now, if it is to do with dimension reduction, or if you are looking at various different prediction algorithms to be used, right? Depending on the different variables and the observations that you have, what are you trying to do, whether it is analysis or analytics, whether it is probabilistic or whether it is for having more accuracy on the data, whether it is dealing with small amount of data or large amount of data. This one cheat sheet actually provides you some insights to choose the best machine learning technique or machine learning algorithm for solving a particular problem. Okay, so I will not go into this for the time being. Let me take up some examples which will help you in understanding how it is applied in the industry, various different industries. Let me talk about something in a retail or a quick service restaurant. Some of the challenges that these FMCG and retail and quick service restaurants all face is sales insights analysis. Now I'm talking about analysis, okay? Yeah, unable to utilize real-time and accurate data. There is data that gets generated, but I'm not able to use it. Product sales insight, menu item preferences. If I go into a retail shop, for example, a retail outlet, a walk-in retail outlet, how will the supply in the back end know which is the fast moving goods, and if any of the aisle there are empty racks, right? Performance for different day part, which part of the day has demand for which product, Yes, these are all very important insights that I need to have so that I don't lose out on my sales. I don't lose out on my my revenue. And performance of product groups. Product groups could be, for if I talk about retail, it would be if it's a multi-brand, multi-product retail shop, the product groups could be one in the clothing, one in housing, one in probably eatables in FMCG, toiletry in FMCG, digital products, and a whole lot of stuff, right? There is so much that is needed at runtime. So sales insight analysis, demand forecast. Once I do sales insight analysis, demand forecasting becomes very, very easy. Demand forecasting to improve their supply chain planning. I already spoke about supply chain. Where it is useful in such scenarios. Demand forecasting would also help in reducing wastage. What is the point in keeping a product which is in no demand? It is eating my real estate and it is eating into my inventory. It's like dead investment. I don't need it, right? Rather, I would keep something which is in demand. Especially in India, we all know festival season, we exactly know what people are going to buy. So that is some intelligence that we have built over last centuries. I don't need to predict, or I don't need to do any forecasting for a festival that we would celebrate in India. We exactly know what people will come and buy. Yes, right. So, but whereas in retail or quick service restaurant, it keeps changing. Now, product price point analysis, because there's so much competition outside. I'm not the only one, right? In retail, I'm not the only one in the fast food restaurant. The quick service restaurant is basically the fast food restaurant. There are multiples of them, hundreds of them. And we are already working on thin margins. And there is no scope for any errors. So if my product price point analysis is haywire, I will not only lose out on my customers, I will lose out on my business, and I will start making loss. If my price is high, probably I'll not sell much, and I would not have a break-even point. If my price is low, I would go into loss either ways. So it has to be really in a very tight compartment with very less leeway for any price point that can give competition an edge. Right. The fourth one, upselling and menu recommendation. Yes. Whenever anybody comes in, you always need to look at, I'm talking sales, okay? There is always a concept of upselling. You go into a retail shop and you buy more than what you needed. This happens. That is exactly what they are doing. They're doing a lot of analysis in the back end. You go and you want to go and purchase probably gehu, atta, dal chawal. You end up purchasing tea, sugar, and probably corn, and probably biscuits and all of it. That is some upselling that you need to do, because it's the average revenue per user is what is being analyzed in the back end, which they would want to increase. Now, these are some challenges. Okay. Now, is there a way that it can be solved? Yes. Let's take a look. I will run through. What is the time limit I have? How much more time do I have?
Sir, actually, your session was scheduled to end at 8. So, but we can continue for 10 or 15 minutes more. That's not an
okay. We started late, right? We started.
Yes, sir, we started late, so we can.
So it's still 8:10, and I have another 5-10 minutes more.
Yes,
that I
we
can.
also have a few questions here. So after your session, you can take.
Yes, yes, yes. So we are all coming to data-driven strategies, right? So let me take one by one. I will just take that of a restaurant. The classification technique. You saw the machine learning cheat sheet earlier, right? So I will use a classification technique for discovering sales pattern. Now look at this: menu items, sales history data. I need to know some historical data, and then I would do some classifications. Now, why are these classifications important? Is for me to exactly know the product group and the product in terms of the day sale, in terms of high sale, in terms of high demand, and in terms of no demand, right? So classification algorithm helps to classify data with users' business rules. Now I have some business rules that I need to follow, right? A tree algorithm is well suited for this purpose. The decision tree or even random forest probably, as it resonates well with connecting with all of the departments and the business in a retail restaurant as such. Okay, so if I were to look at sales insight, I would look at a classification tree algorithm. Okay, now if I were to look at demand forecast, I'm looking at forecasting. This is not analysis, this is analytics. For that, I have linear regression, logistic regression, and a few other algorithms, but a simplest one would be a linear regression analysis, which allows the QSR operators, basically the quick service restaurant operators or the retail operators, to label data into different menu items. Look at the way it is being analyzed from the historical data into the sales forecast with a little bit of margin of error of probably 5% here and there. So multiple linear regression is recommended, right? Because of multiple independent variables that are acting on each of the product, each of the customer preference. Multiple independent variables. Now, independent variables and all of it is something basic, which we're not going to cover now. So nevertheless, the application of linear regression or regression algorithm helps us in analyzing historical data and predicting the demand for tomorrow or for the rest of the week, kind of a thing. Okay, product price point. Now, this is where a clustering algorithm, which is a unsupervised algorithm, which will help us in grouping and clustering with similar characteristics, will help us to ensure that I am not too low in price, nor am I too high in price, right? Which will help us with the K-centroid, and then looking up to applying the K-means algorithm to generate the best possible price range that I can play around with. Okay. Now, upselling and menu recommendation. Now, look at this. A priori algorithm is a classification algorithm, which is best suited in such kind of scenario. And many of the e-commerce engines, be it the Flipkarts, the Amazons, or even Google for that matter, uses this in the backend. They don't use only this, but this is one of the algorithms that they use after I analyze the historical data. Yes. So analysis and analytics go hand in hand. So in summary, what could be the recommended machine learning techniques or algorithms for each of them? When I talk about sales insight analysis, I will go with tree algorithms. When I talk about demand forecast, I will go with multiple linear regression algorithms. These two happen to be supervised learning, one being classification, one being regression. When I talk about product price point analysis, which is, though it says analysis, for me it is analytics. So I would look at the K-means algorithm, and for upselling and menu recommendation, I would look at a priori algorithm, both of them being unsupervised learning algorithms, one being clustering and the other being association. So in summary, this is what these are some of the machine learning techniques, algorithms that are used for various different activities or various different stuff, which is analysis and analytics being done in the backend. Okay, let me also talk something about what Government of India is doing. Very interesting stuff. AI in governance. We spoke about machine learning in supply chain, machine learning in retail and quick service restaurants. Let's look at how it can help in governance as well. Government of India, look out for this, India AI. It's a industry government-led consortium, which is working on various different aspects, various different focus areas. And there are 21 use cases in 7 sectors that they have identified: law enforcement, public sector, environment, agriculture, education, energy, and healthcare. Now you can go through this, and the best part is you can participate. I remember somebody asking about a question as to professors get a lot of recommendations or a lot of applications for internships. What could be the best way of doing it? Probably participate in such government-led initiatives. And there are hundreds of them. The problem is we don't know. Government of India is doing a Herculean task. And it's our responsibility that we have to be part of it. Nevertheless, having said this, let me talk about what it is. Scope of artificial intelligence in India. This is what they have figured out. Automated grading, chatbots in the home, healthcare, education, manufacturing sector, transport, agriculture, AI online course, AI in cybersecurity. Probably the best thing that you can all look at is to create a simple chatbot. You can find a lot of free to use tools, free to use code on GitHub. You would have a lot of these data sets that you can use through Kaggle. There's a lot of data that you can use from data.gov, data.gov.in, data.gov.uk. It's all free, open data, which the government is asking you to use it. Pick up something, think of a problem that you can solve. And Society for Data Science can definitely help you in probably providing you some insights as to what can be done and how we can work together on any of this. Maybe Dr. Amol Goje and Dr. Neha Sharma can add on to it at a later point in time. But yes, opportunities galore, umpteen opportunities, especially when you're students. You have a lot of time. Yes. And if you complain you don't have time now, then you forget about talking about time after you get into a job. And if you don't use your time properly now, you will have a lot of time later on because you will have no job later. So make the best use of your time now. And there are opportunities. And these are some opportunities wherein you will get recognitions, not just the certification. There is a lot of learning that will happen. There will be a lot of mentoring probably you can look out to from S4DS, of course, but such platforms will also help you. Okay, so that's it from my side for the time being. I look forward to these questions now. Okay. Okay, where do we do this?
I'm just taking the questions. And
yes, please. That'll help.
Yes, sir. So the first question comes from Saptarshi. So he's asking, what happens when your analytics data goes wrong?
What do you mean by analytics data? It is mainly the data that is fed in, right? It's the data that you need to clean, you need to prepare, you need to process, you need to pre-process, you need to manipulate, and then feed it into machine learning algorithm. Only then the machine learning algorithm will provide you with any meaningful insights or any meaningful outcomes. Otherwise, it is gibberish, right? So good that you asked me this. What will happen if it goes wrong? Of course, if you feed in wrong data, you will get wrong output and everything will go for a toss. So what you need to first look at is the data engineering part of it, which is data wrangling, which is cleaning up the data. If you look up to statistics, anywhere between 65 to 80% of the time of every data scientist as of now goes into data cleaning, which is mainly data wrangling process. The data preparation, the data pre-processing, data cleaning, data manipulation, handling null values, handling outliers, all of that takes away close to 80% of your time. And once I do this, I don't have to worry about this question at all because I'm feeding clean data. And the machine learning algorithm will do the necessary thing. So I need to know what my data is. I need to clean up the data to an extent that my machine learning algorithm will recognize the data in a way that it wants. It is that machine learning algorithm. And then the necessary outcomes will be as per the intended purpose, as per the objective, as per the business need. Else, it's like no use. Okay, I hope I answered the question.
Yes, sir. And the next question comes from Vishal. He says, sir, how the supply chain is related with the machine learning algorithms?
Oh, well,
I think
well, everything is related to machine learning these days because any data that gets created is fed into some or the other machine learning algorithm at the back end. right? I think I covered this in detail. Maybe it
Yes,
was
sir.
asked
So
before I went to
it was asked
the
before
details.
the.
Yes. Okay. Yeah. Thank you.
Then we have Shatadeep who asks, do predictive analytics and prescriptive analytics go hand in hand?
Analysis and analytics actually go hand in hand, right? So whatever you look at depends on the business need, the business objective, the problem at hand that you want to solve. So keeping all of that in mind, there are a few things that would go hand in hand. My analysis and analytics go hand in hand. So definitely my predictive and prescriptive also would go hand in hand, depending on what is the need or what is the research that you're doing. Whether it is to stop at what may happen or to go to ask the question as to how will it happen, right? So it's the questions that you need to ask yourself before you try to find the answers through machine learning techniques. So there is a lot of non-technical stuff also that you need to apply your mind on before the machine learning takes over. After all, machine is a dumb thing. We may talk about artificial intelligence. It may be intelligent, but it is still artificial. Yes, there is no replacement to human natural intelligence.
Yes.
Okay. Yes.
So the next question comes from Shomadeep. He asks, what is your view regarding the rather ambitious prospect of using machine learning in the domain of medicine for the detection of potential diseases and their early diagnosis in a field that requires inevitable human intervention, as well as the lack of balanced data causing the models to overfit or incorrectly generalize on skewed data?
Oh, wow, this is a very good question. And probably you did some predictive analytics before you asked this question to me, because I come from this industry. And my PhD topic somewhere lingers around this. And happy to mention Dr. Amol Goje is my guide, and we are actually working on building a platform which can handle all of this. Nevertheless, coming to the question, it is a very difficult area to actually get my machine learning efficacy and accuracy to work. If it was my supply chain, if it was banking and finance, if it was to do with transport, supply chain management, governance, 90% accuracy would be like, wow. It's like machine learning. After I apply a machine learning technique, I'm getting 90% accuracy, 90% fit, right? It would be like, oh my goodness, I have achieved like the Nobel Prize. Whereas 90% in healthcare, especially in medicine, is like thrown out of the window. It doesn't even come near when we talk about accuracy. My accuracy in healthcare and medicine has to be not even 99.9, it has to be 100%. And we are still to figure out a way as to how we can get a machine learning algorithm on a set of data set, whether it is for prescription of medicines, or for analyzing a digital MRI or a CT, or maybe decide on the care pathways, or decide on what could happen tomorrow, especially in cancer treatment, or for that matter, a pandemic of this kind, right? We are still not there. There is at least a decade or more of work in the medicine and healthcare industry before we can fairly say that, yeah, a few machine learning algorithms or a few machine learning techniques would be best suited for all this. To a large extent, some of the computer vision algorithms are being applied onto digital images, which is mainly pattern recognition and stuff like that. To a large extent, that is working well, but nothing beyond that. Okay.
Yes.
A long answer to a very good question.
Yes. So we have two more questions from
Okay.
Vishal again. So his first question was, sir, does the prediction algorithms goes wrong? Certainly. So I think he meant about the.
Oh, yes. Yeah. Prediction is just like a gamble, right? It's a probability, right? It may come correct, it may go wrong. 60% accuracy, 70% accuracy. That's something we build as we keep applying and improvising our algorithm and the data set. So prediction is, if you were to look at supervised algorithm, I look at the test and train split, which would mean that for some data set, the accuracy would be the highest when I take at 75-25 ratio. Whereas for a different data set with the same algorithm, I would need 60-40 ratio of test and train kind of a split. So yes, this is an iterative process. So generally, I would start using an algorithm on a data set. Of course, after the pre-cleaning and after the data wrangling, data manipulation steps, I would start applying it in an iterative process, starting from 60-40, 70-30, 80-20, 75-25, 65-35 kind of range. And then I would see what is the accuracy, what is the score in terms of the highest one is what I would prefer as the model to be applied on that particular data set. That can't come to a thumb rule saying that 75-25 is the best ratio of a test and train model for every data set. No, there are a lot of parameters, right? So it could be independent variables, it could be multivariate variables, it could be the number of observations, it is the business problem that you're solving, it is the objective that you want to achieve, it is the insight that you would want to look up to, and so on and so forth. So it's a multi-dimensional problem that you are trying to solve. So predictive algorithms will go wrong initially. After probably some 60-70 iterations, you may go to an accuracy of 85, 86, 90%. Yes, and that's the job you all have. That's the job you will all be hired for. Look at it that way. Okay? Yes, let's go forward. Yeah.
Okay, so
Yes.
Vishal, if you would like to ask the last
Yes,
question.
yes, I just want to ask a different question right now. Like talking about accuracy, sir, is the blood sugar machine or the blood sugar checker how much accuracy does it have, and if it is containing a machine learning in it, like everyone used to tell that it is used to show random measures, and we have to just add 10 or subtract 10 from it to have the correct measurement over there. And earlier you have mentioned that if you're making a machine, it should be 100% correct according
Yes.
to the medical field.
That's right. Yeah. So don't believe any of the variables or any of these machines that you have at home. They are not yet to the level of accuracy that is needed. That's why when you take the results to the doctor would say add 10-15% here and there. And they would want you to get the test done in a diagnostic lab once again. Right? That's because the doctor doesn't want to take any chances with this data, even though it may be accurate. I don't know, because there is a lot of calibration that needs to be done for these equipments. The calibration is done on a daily basis in the diagnostic or in the laboratory in a hospital. It is quality checked every week by internal and external agencies, depending on the workload. So there is a lot of process that needs to be followed to bring about that accuracy, efficacy. They don't even talk about accuracy, they talk about the efficacy. Now, if my data is wrong, my treatment will be wrong. And if my treatment is wrong, I'm putting the life of the patient at risk. Who will take that responsibility? Doctor would definitely not want to take it. And that's why this particular aspect, as I told you, it is at least a decade, if not more, to lead to that accuracy. What has helped is robotic surgery. What has helped in radiology diagnostic? A lot of automation has happened. Not on any of the data from the pathology lab or any of the data from the wearables or from the Internet of Medical Things that we all use. Right? Yes. So don't believe those numbers. During pandemic, I'm sure many of you at home, you have you have bought the bought the oxygen saturation, SpO2, and your BP and all those small kits, and you would test it out. Even if you put a pencil or a pen into it, it'll give some reading. Does that mean my pen or a pencil would have oxygen saturation in it? Well, not necessarily. Yeah, right. Yes. So that's the intelligence we humans need to use. Don't completely believe on artificial intelligence. That's the bottom line. Okay, I think that's it for today, right?
Yes, sir. That brings us to the end of today's session. Thank you so much, sir, for joining and taking time of your busy schedule to
Sure.
give us this such insightful knowledge on these various topics. And Shomadip, please share. Yes, thank you. And I would like to ask Neha ma'am to present Atul sir with the token of gratitude.
Thank you so much. It was really good.
I think Neha ma'am is not available right now. So Amol sir, would you please do the honor of presenting Atul sir with the token of gratitude? Thank you. I think, sir,
Yes.
that both of them are not present in the meeting. So
No, they're there. I can see, I think. Nevertheless, it's wonderful. It's like this is my home turf. I'm part of S4DS any which ways. So this is my family. Dr. Amol Goje, Dr. Neha Sharma, Amlan, Saptashri, all of them, right? We are all family. So no formalities. Thank you so much. My pleasure to have presented and interacted. If there are any questions, feel free to share it even at a later point in time. S4DS will be more than happy to not only answer, but also engage and look for more such interactions. And some things need to come from your side as well, in terms of projects, in terms of ideas, in terms of some exploratory work that you need to be doing. As I told you, you all have a lot of time. Don't waste it. Don't waste by creating data. What does that mean? That is mainly not going on to social media. Just shut off from social media. You don't need it. Somebody else is learning from you. Somebody else is analyzing you. Somebody else is using your data. What are you doing? You're not doing anything. You are the feed into it. No. As part of the student chapter, I presume you're all interested in data science and the application of data science. So come on the other side of looking for data, analyzing data, manipulating data, analyzing data. Use all of it that we spoke about, and we will be more than happy to be part of any of your journey. Okay. Thank you so much. I take leave now.
Sir.
Okay.
Thank you, sir.
See you. Bye-bye.
thank you so much, sir, for joining.
Okay. Yeah.
Good night,
My
sir.
pleasure. Bye-bye. See you. Yeah.
Thank you, everyone else, for joining as well. So
So
we
the
have
session
our
is officially ended now. And sorry, Nirmala, for interrupting.
no, it's okay.
So our session is over now. And for attendance, the link has been shared in the chat link in the chat box. Please do fill it up. And if you don't get it, please do mention it. We will share it again.
Yeah, and we'll have sessions on next Saturday and Sunday as well. On Saturday, it will be on explainability in AI, and on Sunday, it will be on community building in the field of data science. So, two more interesting sessions to come up. So, I think you enjoyed today's sessions as well. So, thank you so much for joining.
And hope to see you again next weekend. Same time, 7 p.m. to 8 p.m. 16th and 17th of July.